My name is Hanchi. I will today give you the class about Introduction to Large Language Model. This is kind of a general introduction, and we just provide some basic information on what is large language model, what is the difference from like other existing models, and I will also give you some practice tips to use in your work, in your study. Okay, let's start. Let's first talk about the background of this arrow. What's the arrow? It's arrow of big data. The widespread use of various digital systems leads to the use of big data. We know that in companies, people always use like ERP systems. They try to use those to communicate with other people in the system and try to arrange all different resources in the company. And it's not only a professional design, but also for personal use. I can see that everyone here is using laptops, and I think also use smartphones. They are all devices that not only produce data, but also consume data, which means that now everyone here is now the consumer and the producer of data. And we know that data is informative. We can learn a lot from the data, and we can analyze the trend. We can learn something that is not discovered before. But we also need the big theory to convert data to knowledge, because sometimes data can be in a mess. It can be long and hard for us to use. So if we can convert data to knowledge, then we can understand the process. We can make prediction for the future. We know that there are some very common big data use cases. For example, people use it for fraud and compliance. We know that sometimes there are some spam email, spam phone calls. I think everyone from time to time will receive some. And we know that people are trying to create algorithms that can help us filter out those fraud and spam emails. And it can also be used for compliance, like check whether the process within a company follow all the regulations and the laws. Another example is customer experience. I know that many people now like to use those different apps. Some of them have the recommendation system. For example, if you use some app to watch some short videos, it will try to learn what you want and try to give you some recommendation based on what you watched before. That's another use case. One more use case is predictive maintenance. We know that in a factory, we always need to fix the machines from time to time. But if we just try to fix everything from beginning to the end, it may cost us actual cost. But the use of big data is that if we can learn from the data, and then we can know which machine is highly likely to go wrong next week, then we can focus on those and only schedule maintenance for the critical part. So we know there are a lot of potential for big data, but we also know that it's not such an easy job for humans to learn everything, because there is a complexity of learning. Here are some examples. We know that human expert sometimes just does not exist. For example, before people go to Mars, nobody knows all the details. So they cannot say, okay, I have an expert knows everything. I just ask him or her and everything is solved. It's not the case. But if we can try to learn from other domains and try to gather knowledge together, then maybe we can learn things that human beings never did before. The second case is that humans are unable to expand their expertise. One example here is speech recognition. I know that everyone can understand what I'm talking now. I hope so. But we know that sometimes, even if you can understand what I talk, you don't know how you understand it. It's very complex activities within your neural, within your brain. Okay, you know the output is that now you can understand what I said, but maybe you don't understand everything happened in your brain. In that case, we also need to try to find a way to learn, because it's not like I am an expert, and then I teach the machine learning algorithms, and then they can, okay, based on what you said, I'm very clearly that how to learn to listen to other people speaking. It's not that case. It's much more complex. Another example is sometimes the solution change in time. For example, routing on computing network. The case here is that when you try to create an internet, a network, it sometimes needs to connect a lot of the routers. And it's very complex interaction, and you have to find the real-time solution on time. And it's very difficult for humans to really learn every detail about, oh, this signal comes from this computer, and it's a destination to that computer. So I have to draw a line. It's not the case. It needs computers to do the calculation in real time and arrange the route. The last example here, a solution needs to be adapted to particular cases. For example, we know that sometimes we use our fingerprint to unlock our phones and other devices. But the problem here is that everyone's fingerprint or other biometrics are so different, and the difference is in details. Of course, you can just read it and compare it with the example in your database and say, oh, this is maybe this is me, this is Professor Miklos, this is Harry. But it's also very complex, and you have to compare a lot of different cases. So it's not effective if we use human to do that. So the 4 examples here is that the learning is a very complex process. It's not such an easy thing that you can just very simply tell people how to do it. Therefore, we developed the idea of machine learning. So what is machine learning? Machine learning is programming computers to optimize the performance criteria using existing example data or past experience. So it means that you give the computer, the machine, some existing data, and they does not learn from humans' instructions, but learn from the data. And based on that data, they can help us solve future problems. So why we say it's the era of big data is because now data is cheap and abundant. Remember, I said that everyone is generating data in your smartphone, in your laptop, all the electric devices. So data is now much cheaper and abundant. The second is knowledge is expensive and scarce. So we know that there are so many different data, but to have good use of the data and try to create some knowledge and use the knowledge to maybe create a new application, make people's life easier. That's not easy. That needs people to work hard. So the advantage of machine learning is that it can reveal large volumes of data and identify patterns and trends that might not be apparent to a human, and it can improve the accuracy over time. For this is because we know that if we can consistently improve our algorithms, if we find there's something wrong with the algorithm, we can change the settings. This is what people are doing in computer science. And also, if we find the training data has some problems, if we find, okay, the data we use to train the model is not good enough, then we can add more data to the training side. Also, it can improve the performance of the machine learning. And another good thing is that it does not need the humans to consistently give it instruction. Sometimes you just let it running and feed it with new data. It can automate the process and always improve itself. Okay. Now we have we have introduced the big concept. Now we can give some more detailed examples. I want to help you learn more about machine learning by first comparing it with another older system called expert system. To be more precise, it's a rule-based expert system. So what is expert system? Rather than attempting to identify new patterns and then classify data based on statistics or operational experience, they are designed to replicate the problem-solving process of experts in the field. So we can say that, okay, we have a human expert who knows everything about this. For example, like it's a medical doctor, and he or she knows all the details about, based on your symptom, what is the disease you have, and how can we give you drug, how can we give you some treatment. And then that human expert need to summarize everything he or she knows into a written like a flow chart or like detailed decision tree. And then they put those rules to a knowledge engineer. And then we just write it and use very clear rules, conditions. And then we set everything one by one to the computer. And based on those rules, people can use computer to solve the problem. And this is called expert system. So we think that this is all based on known rules. And it's a direct application of existing knowledge. It do not attempt to learn directly from the data. So sometimes people argue that machine learning can yield new insights and might be missed by a human. But machine learning needs sufficient data with good accuracy and representative. So here is the difference. If you use expert system, then the most important thing is that you should have a real expert who knows as much information as possible, who can solve this type of problem perfectly. But for machine learning, it's different. You may not have a perfect expert who knows everything, but that machine learning algorithm can learn from a lot of existing data and try to see how to solve this type of problem. Here, I try to use an example to help you better understand how you can use the expert system and the machine learning together. Because sometimes it's not separate. There is one type of machine learning algorithm called rule creation algorithm. In that case, they try to do like a human expert. They learn from data and then they create the rules. And then they use the rules to solve the problem. So here is an example. You can see in this table, I create a very small data set of transaction. We have 1, 2, 3 different transactions. Then we have attribute 1 and attribute 2. Attribute 1 is like yes, no, no. Attribute 2 is like high, low. There are different metrics. And then we have a label, which is whether it's fraud or not. And if we try to combine expert system and machine learning together, we can actually use the machine to generate rules like human expert. So after they learn from this data set, okay, then they understand how to create the rules. Like for attribute 1, if it's yes, then it's fraud. For attribute 1, if it's no, then we should go to the next level of conditions. If it's high, maybe it's fraud. If it's low, it's normal. For some domains, if there exists very clear rules, it can be not, right? Sometimes it's so complex that you cannot generate a rule like this. But for some domains, it's possible. Then you can use the rule creation machine learning to create such a decision tree. And then you can help people create a rule-based system to solve future problems like this. So we can say that computers are able to create systems, just learn from data. And the key to the success of machine learning applications, like I talked to Keenan, is that we should have enough data. We should have less noisy data. It cannot be, okay, 20% of the data is wrong. Then the machine will be misled and learn the data in the wrong way and give you a wrong algorithm to solve future problems. Sometimes it can be a perfect solution when you have limited time and money. Of course, you can, for example, if you try to have a security and check everyone who go into the building, of course, you can hire 2 security persons and they just sit there 24 hours a day and check, okay, this is someone from our company. This is not someone from our company, and let it go in and out. But if you don't have enough time to hire everyone here and don't have enough budget, maybe a solution is that you just use face recognition algorithms and a camera in front of your company's front door, then people can also recognize whether this is someone inside this company or it's just not someone inside the company. Okay. Based on the example that we can combine machine learning and an expert system together to create rules, it can also say that maybe traditional method and machine learning algorithms can benefit each other. They are not one replace another, but we can put them together and solve some problems. Okay, so far we have introduced a basic background. Now I will try to introduce to you what is large language model and what is like the famous large language model ChatGPT. But before we go to the large language model, why don't we go to the other side? The task-specific AI, which is the models appears before we have large language models. Then I can give you a comparison of what is task-specific AI. And then we can know the development of generative AI, like more general AI, like generative AI, and give you a comparison of what is new, what is different. Then we will have some latest research frontiers, and we will give a very simple guide to the practical applications. So large language model is a type of artificial intelligence model that's designed to understand and generate human-like text. In the early version, it's basically trained based on textual data. But now we know that they are also trained on images and many other different data types, data modalities. So the starting version are based on a type of neural network called transformer, which use self-attention mechanism to understand the context and meaning of word in a sentence. So just be easy to understand. This means that this type of algorithm can help the machine learning algorithms very easily catch the meaning of the text. It's not very easy understanding. Okay, we understand the word apple, and then it's a fruit. It's not like this. Based on this algorithm, they can understand each word based on the context. So they know that sometimes the apple means a fruit, sometimes apple means the apple company. So this algorithm can have the ability to help people, help the model understand different contexts. And we know that example of early LLM include like GPT series by OpenAI, bought by Google, but now they have Gemini, and also at that time it's still called Facebook, but now it's more like Meta. They all have their own models developed in the early age. So we think that this is very important that everyone knows that, because large language model can understand and generate text, and it's very similar to humans. And we believe that it can help human workers solve some problem like process textual data and summarize text, translate languages, and a lot of other things. You can also use it for entertainment, like create some stories, create some poetry. And in the context of accounting and auditing, we find that large language model can automate many different tasks, such as data entry, document review, and financial report generation. Therefore, they can help us automate the system and increase efficiency and reduce errors. Before we go to the technical details about like more general AI, we should talk about what is task-specific AI. So we can do a comparison later. The task-specific AI is designed for one specific task. Examples are like earlier version of Siri, where you can only ask it to, okay, call someone or just show you something. Everything is programmed. It's not a very flexible system. And like if you play the game, maybe you know Go, and there's a famous algorithm called AlphaGo, which try to compete with human Go players. It's kind of a chess game. And the model can only play chess. It cannot play other games like cards. It cannot play like video games. And for facial recognition software, they can only read your face. It's not like, okay, if you can read the face, why don't you also read my dog's face, right? It's similar. It's similar, but if it's not trained based on animal's face, then it can only do the task for human beings. So To summarize, it cannot perform tasks outside its program domain. And this is the most popular and popular applications in today's AI apps. But we know that we have another type of AI called general AI. Although general AI is not well developed, but it can already have some applications in domains like textual data, right? ChatGPT is a kind of general AI in textual data. And it can mimic human cognitive functions, can perform any intelligence task human beings can, and it can be adapted to unfamiliar tasks, even if we did not train any task based on this type of data. However, it's still theoretical. There is no existing general AI that can solve all different types of problems. It's still like a little more general than task-specific AI like ChatGPT. It can solve a lot of different textual data problems, but it's not so well developed to solve all types of problems in one model. So if we look at the classification of task-specific AI, we can say machine learning can be divided to different categories. For example, we have supervised learning, and we have unsupervised learning, and reinforcement learning. In the next slide, I will give you some detailed information about what are those algorithms work, what are the targeted scenarios. First, let's look at classification. Classification is the task of assigning object to one of several predefined categories. Examples are that it can detecting spam email messages based on the message handler and content. It can predict the probability of human future bankrupt, a company's future bankruptcy. It can predict future default of consumers. So if we say what are the important things we should have in a classification model, is that we should have a collection of records, which is a training set. And we should have a cube of X and Y. X is the attribute set. Sometimes it's also called predictors, independent variables inputs. And we should also have a Y. Y is a class, is a response, can be called dependent variable, sometimes called output. And our task here is that we want to learn a model that maps each attribute set X into one of the predefined class label Y. I will still use a transaction table to give you an example. Here, the training set is that we have 5 different transactions, 1, 2, 3, 4, 5. And we have 3 different attributes. The first one is like a binary attribute, like yes or no. The second attribute is like high, low, medium. And the third attribute is like a number, like 100, 125. Then we have the Y, which is a class. Here we have 2 different classes, for example, yes or no. But in real world, you can also have data set that will have more than 2 classes, maybe 3, maybe 4, it's all possible. And we just want the model to learn from this data. Oh, of course, in real world, the data set is much more larger. Here, I just show you an example, so it's a very small data set. And then we let the model to learn from this data set, train based on this data set. Then we give it a new data set, which is not included in the training set. It's called test set or testing set. And then our purpose is that, okay, we have this new data set, but we don't know the class. But you already learned this large data set. So why don't you give us some prediction of the class of this new transaction? And we think that the classification model can help us assign each transaction in the test side to a class which is most likely to the transaction belongs to. The second kind of supervised learning is this regression analysis. Regression analysis is a statistics method that helps to analyze and understand the relationship between 2 or more variables of interest. The process is adapted to perform regression analysis, helps understand which factors are important, which factors can be ignored, and how they are influencing each other. Example is that it can use it to predict future revenue. calculate a score, which is for the rate of a given transaction. And they can use it to predict annual income for a subsidiary. So if we will use one sentence to summarize, the task here is learn a model that maps each attribute set to a continuous value. It's different from classification. If we try to use a transaction example to show you, it looks like this. Still here we have 5 different transactions in the training set. And we have 3 attributes. They are different. Some of them are binary, some of them have more than 1 class, more than 2 classes, and some of them are numeric. But the difference here is that in this data set, we are not trying to do a class, but like a score, maybe a risk score, maybe a score to predict future behavior. And we have like 18.8, 16.5, 14.4, 15.4, 16.4, like this. And we feed this data set to the machine learning algorithm, the regression model. Our purpose is that given a future data set, a test set data set, we want to know what is this score for the new data set. And we think if we use the regression models, they can learn how to give scores and give scores for this new testing data set. So the score is different from classification because the regression model is more like try to fit a curve. You can see that we have different transaction points here, and we try to find a suitable curve, and based on the existing data set. Then in the future, if we have a new point here, we can predict what is the value for that point, like transaction. But for classification, the purpose is different, like that. We are not trying to fit a curve to the existing data point, but we try to divide them. And we want to find draw a line that can separate different types of transactions. In that case, we think that a label data set Y is discrete. And the common point of the 2 types of algorithms, regression and classification, is that they are supervised learning, which means that they all have a Y label. In classification, it's a class. In regression, it can be a score, but they are all called supervised learning. Then I will show you some different parts. It's called unsupervised learning. The first example of unsupervised learning is clustering. The clustering algorithm is trying to find groups of objects, such as the object in a group will be similar to another and different from or unrelated to the object in another group, which means that we try to divide the data set into several groups. And each of them within the group should be similar. But if it's in different groups, we try to make them as dissimilar as possible. Example here is that sometimes we can use it for span filtering, but in a different work mechanism compared with classification. In classification, okay, we already know what are the existing data of spam email, what is not. And then we try to divide each new email to one of the class. But for clustering, it's different. We just put similar things together. And we find, okay, the 98% of the emails are like normal email, and we put in a big cluster. But we find maybe 2% of them is in another cluster. And then we just say, okay, those are similar emails, and maybe they all belong to a different group. And then we can investigate on this. And it is also used for marketing and sales. Sometimes people just want to cluster similar consumers together, right? Maybe they try to decide different products for young men, for young lady, and sometimes for old men, for old lady. And it can also be used for identifying fraudulent and criminal activity. And it's just similar to a spam filter. Also, we can use an example to show you how it is different. Look at the data set. Now we have 6 transactions in the training set. And we still have 3 attributes for binary class and a numeric attribute. But the different part is that it is unsupervised learning. So you can see that we don't have a label like a score, like a class. We only have the attributes, but we don't have targeted Y. And if we use clustering algorithms for this data set, we can say, okay, now the algorithms help us divide the transactions into 2 different classes. And 1, 2, 3 may be similar, and 4, 5, 6 are similar. Then we can use this algorithm for further analysis and based on different classes. Okay. There's another type of very special unsupervised algorithm called unsupervised outlier detection. So by definition, an outlier is an observation which deviates so much from the other observations as to arouse suspicious that is generated from a different mechanism. So we find that this is also very similar to when we do auditing, because in auditing exception, transaction anomalies are all outliers. An outlier often contains useful information about abnormal characteristics of the system and the entity. Abnormal debit credit amount, like occurrence time, the counterparty's exact, and possible reasons are mechanical fault, change in the system behavior, fraudulent behavior, and human error. If we still try to use transaction data to show you what it means, it looks like this. The training set is 6 different transactions. And if we use the outlier detection algorithm to run on this data set, then we can have this. We find which data point is most abnormal compared with other data sets. You can see that we find transaction 4 is the deviate most from other data sets in other data point in this data set. And this can be very useful because sometimes we just want to check what is the abnormal transactions in our data set for further analysis. And then we can use the outlier detection algorithms. I think besides supervised and unsupervised learning, there are also some new innovative machine learning algorithms. For example, reinforcement learning. Reinforcement learning is a machine learning training method based on rewarding designed behavior and punishing undesigned ones. In general, a reinforcement learning agent is able to precise and interpret its environment, take actions, and learn through trial and error. I want to use this graph to show you like different from the existing algorithms like supervised, unsupervised. This is like more like a dynamic process. You can keep running the algorithms and then get feedback and improve the existing process. I will give you an example here. Think about that we try to do resource management within a company, and we have 3 different tasks to complete in this company, 1, 2, and 3. And we also have 3 types of resources to allocate for the 3 tasks: resource 1, resource 2, and resource 3. Oh, sorry. And then based on this data set, we can first give a starting point. We give a starting point like the arrangement like this. And then we keep run in the system. Oh, sorry. Run in the system. And then to see how it goes as a reward. Maybe the reward is the efficiency of the company. Maybe it's the profit. And then we see whether it's good or not. And then we can continuously change the resource allocation. Sometimes we reduce a little bit for task 1, gives more to task 2. And then we keep running until we think the resource is good arranged, allocated. So it's more like dynamic for reinforcement. Okay, so like we said before, general AI's purpose is more like mimic like different human cognitive abilities, and we try to perform any intelligent task a human can. Although it's not now completely realized, we can do that for some specific domain like textual data. And for large language model like ChatGPT, we think that it's useful because it helps some general understanding within the domain of textual data, and it can solve different tasks. But we find that sometimes it still has some limitation, like it lacks a consciousness. It's reasoning like human. Sometimes it cannot have the understanding when we go out of the training data set. So let's have a very basic understanding of the techniques of what is large language model, how it's trained, why it's different from existing data. For existing task-based AI, we know that, okay, we have this type of problem, then we only give them this type of data, and they train based on very narrow down domain, and they can complete tasks in this domain. But for large language model, it's different. By the way, large language model belongs to a more broader category, which is called foundation model. Here we put all different data sets, like different text, different images. We can even put speech, structured data set, like all 3D signals, everything into the training set. Because of the transformer algorithm and other powerful algorithms, it's possible that you just dump the data all together and train a very, very large model. And then after we have this model, we can also use them for so many different domains. We can use them for question answering, sentimental analysis, information extraction, image captioning, object recognition, instruction following. So this is more like we train based on much larger data set, and then we have much larger model, and then we can use it for a much wide domains for different tasks. Okay. So maybe we can have a look at the development of GPT models at this time point, and then we can understand why is it such a promising domain, why is people said it have great potential. GPT-1 was the first model, right? It is introduced in 2018 by OpenAI with 117 million parameters. GPT-1 was trained on a large corpus of text data set that use unsupervised learning, allowing it to generate coherent sentences and paragraphs. Then we have GPT-2 after 1 year in 2019. And it now already have 1.5 billion parameters. It is capable of generating longer and more coherent text. The release of GPT-2 sparked concern due to the concern about potential misuse for generating fake news and misleading content. Then we have GPT-3, which is introduced in 2020. That was the most advanced model at that time. And at that time, they already have 175 billion parameters. We know that they have some improved version of GPT-3, like GPT 3.52, which is also called ChatGPT model at that time. And we find that it's a very famous model. And it's the time that make everyone know, oh, there exists the product called ChatGPT. And we also find the performance is much better. Later, we find GPT-4, which is introduced in 2023. And the advantage is that it's not only much more intelligent, but also it can be used for multiple data modalities. What this means? It means it can be used for textual data and image data. As I told you before, in the training process, you have to train on all different data types, then they can answer this type of question. Luckily, in GPT-4, they already have like, they can understand like tables, they can understand text, they can understand images. So this is pre-trained to predict the next token at that time people know, and it can use both public data set and data licensed from third-party providers, and then fine-tuned with like reinforcement learning from humans and AI feedback. But also there are some discussions. Sometimes people say, okay, ChatGPT use our data set, like New York Times, like Washington Journals, and they didn't buy our they buy our journal, but they didn't buy for training. So there's a lot of discussion. But because this is not a law class, I don't have the ability to talk to you about the details, whether it's appropriate or not. So we can summarize the development of the GPT series from OpenAI. We can see that at the beginning, 2018, June, they only have 117 million parameters. But after 5 years to GPT-4, they already have By the way, they didn't give us a very precise number of the parameters, but we can estimate that will be in trillions. So we can see that the model is growing so fast, and they are much more intelligent. We believe that they will also have some future development, and they will be more intelligent and can help people deal with different tasks in their daily work. So it shows great potential for the GPT series and other competing large language models. If we give a short summary, the progress of GPT's language models has been significant in terms of size, accuracy, and the complexity of training datasets. GPT models have the potential to automate many tasks previously performed by humans. There are concerns about potential misuse of these models, such as generating fake news and misleading content. Now, I want to show you several latest on this topic and show you how we can actually use GPT models. The first one is called about how people study the new relationship between AI and auditors. We want to introduce based on this paper called Artificial Intelligence Copilot Auditing. I write this paper with Professor McLeod and some other authors. So we all know the concept of Copilot is basically in the aviation industry, right? We have a human pilot, and then we also have at the beginning, it's a human co-pilot. The co-pilot is trying to help is a professional who is trying to help the pilot to lower the workload, to enhance safety, and make the work more efficient. But now later, the co-pilot concept is used in the car industry. We know that Tesla, Ford, Mercedes, and many other automobile companies all have their own co-pilot system, and they can use some AI in the system to help the drivers to drive much easier and more safe with more safety. And then we think that the co-pilot concept is not limited to the aviation or like the car industry, but also in many other domains. For example, the software development industry, the customer support industry. For software development, it can help the programmers write code faster. And for customer support, it can try to help the customer service answer some questions without the need to hire a lot of customer support guys. And it can also lower the wait time for the users. And it can also use to help you do some simple check of your disease. And I know that it has some risk if you try to use the online system to chat with them. What is your symptom? Can you see what is the disease of me? But I know it's not so perfect at this time point, but it still can help people save some time if you think you don't have a serious disease. You just want to have a quick check. What is the And we also have like a Copilot in the smart home assistant. I think you are quite familiar with like the Alexa, the Hi Siri, the Google Assistant. Now they all update their assistant and have something related to large language model, and something can help them do the Copilot. And like general productivity assistant like Microsoft 365 Copilot, they said that now they will update the Copilot function to all of their applications in the Office software family. But we didn't find, at least at that time, we didn't find any application for auditing. We now know that some big 4 auditing firms, they try to develop their own large language model and try to have their own Copilot system. But at that time, nobody did that. So we try to pose the idea that it's possible to do some auditing with a large language model in a Copilot setting. So we try to propose this idea of Copilot auditing, where human beings try to collaborate with AI, and we try to have an explanation what is Copilot, what is foundation model, what's Copiloting, and what are the techniques used. And we demonstrate how to use chain of thought prompting, I will introduce later, to guide the model better understand the auditor's instruction and finish the task. And we also did some basic assessment of the accuracy if we just try to use ChatGPT and helps auditors to finish some tasks. Okay. I will go to the next slide. So I try to use this graph to help you understand how it works. We know that auditing is a very complex task where we want to do a lot of different tasks like general entry testing, financial ratio analysis, disclosure analysis, a lot of different subtasks. And the auditors have to do those by themselves. But we think that if we can use the system to help them, and we can let auditors just give instruction to the model, maybe the models can help them automate those small tasks. And the foundation models, as you know, just learn from exogenous data set, a lot of large training data set, even outside the audited firm. And then we can use them to generate audited report, and then we can give them some information that the model didn't know in their training. We just tell them what happened in the audited firms, about give them the real numbers of bank statement, the lease contract, and some inside data. And the auditors can get the feedback they want. And we already know that foundation model is just a subset, a development of the existing machine learning, existing deep learning. And as I already introduced, I won't spend much time, but you know that it's like general AI. It can solve different tasks. So in our proposed settings, we believe that the auditors and the model can work in a very easy conversational way, which means that it's not, okay, I am an auditor, I learn a lot about programming languages, I become technical details, then I can interact with the model. It's not like this. We want it just use very simple languages and give instructions to the model, and the model can help them solve the tasks. So we show several experiments. I will show you 3 different experiments we did. The first one is about whether it can assist auditors to do some simple financial ratio calculation. Then we try to see whether it can help auditors in post-implementation review. And then we see whether it can help auditors do some very simple general entry testing. The first one is about financial ratio analysis. Because we tell it what the formula should look like, and then we, based on our design of how you can do it step by step, like what's the task, what's the actions you should do, what is the input data looks like, what should the output data looks like. And after we do all the fine tune, we find that they can actually calculate the financial ratios and give us a result. The second part is about post-implementation review, which means that in auditor settings, sometimes people will be given very long paragraphs of textual data. Like, okay, we have project one is in Texas maybe, and then the description is very long, what it belongs to. But auditors don't want to read such long, tedious paragraphs, right? So what we test in this experiment is that, okay, we feed them long paragraphs. And after our fine tune, we find that, okay, they can extract the information, important information from each paragraph and summarize it into the tables or like JSON format. JSON format is just a type of table. And they can find, okay, what is the first plan? The first plan, Texas Municipal Retirement System. And the type is DB in the description. And then we have A, we have city, Arlington City, we have state, Texas. And then people don't need to read the long textual data. They just extract the information they want and put that into a table format, like JSON format. The machine can learn, and they can easily store and use for further analysis. One more example is that we can use it to do some very simple general entry testing. Here we just give them the definition of what I think can be a dangerous general entry, like what is global anomaly, what is local anomaly, just write in details about the definition. And then we put a big data set to the model, and we find that they can extract the related transaction based on our definition. So we think it's still useful for the auditors. So I think maybe we can watch part of this video. Okay, I think it's still. useful to read it.
Hello, welcome to this video.
Oh, by the way, this is another researcher who created this AI research assistant, because I find the interface may be common not only for this app, but also for other apps. So I can give you some examples how you can use it for research and other.
I'm going to discuss how to use the AI research assistant. Before we start, I want to know, this is in beta, so we're just testing and trying to get feedback on where it works, what doesn't work, and we will be sending you some questionnaires to help us out on designing this to make it as useful as possible. When you come to the website, you're going to click on the app and come to log in. My credentials,
Okay, this is
put it up like ChatGPT. Here's your chat window, and over here you have your command center or your menu.
So I think this is just common for the updated ChatGPT applications. Now you can just upload not only your instructions, but also upload PDF and other database, and you can let them answer questions, but only based on the data you give to them. And you can also let them search based on the given data set. I think this is useful when you try to do some work in your own domain. Oh, sorry.
Sure. So you can log out, clear the chat, we'll just get rid of anything in the context. You then can choose to search, upload a PDF, or chat. Clicking chat returns you to this window. Next, you can select the model name that you want to use. We've integrated different models that have different strengths and different weaknesses. I'm going to go ahead and just use the latest GPT-4 model from OpenAI. Down here is your pin board. When you search for articles, you'll pin them over here. What's in their pin board is what's going to be available to chat. So let's go ahead and click search to start. Now this is very basic search. You'll notice that it searches only these journals, and there's different abstracts involved.
Basically they already all those existing journals to the database, so you can just limit what is the database you want to search here. So basically you can not only for academic, but also for others, like maybe you have several different clients, you can put each of them to a separate folders and limit the search within that domain. That's all possible for existing app.
This is built on abstracts. So what we'll be searching against and talking against are the abstracts until we get to PDFs. So I'm going to say I want to search for 10 articles from 1990 to 2023, and I want to search on the idea of earnings management and technology. All right, you'll notice the article comes up with just the abstract, the number of cross-ref citations, who the authors are, and the name, and then the DOI. So if you click on the DOI, it'll take you immediately to the specific article. All right, we're not going to look at the issues in accounting education. We're going to come down and I would carefully think through which articles I'm pinning, but for the purposes of this demonstration, I'm just going to pin several of these articles in the different journals. And you'll notice every time I pin, it puts it over here in the abstract, Counting Horizons, and great. We'll just take those 8 articles. When I'm done searching for articles, I can go back to chat. Now you'll notice it'll say 8 articles in context. Those are the ones over here on your pin board. So these are the ones that you're chatting against. Now doing it in this way gets rid of a lot of hallucinations. You'll notice, for example, I can say, summarize each article in 2 bullet points. In the context, you'll see the context window. Again, this just reiterates, here's the articles that it's considering when it's chatting. Up here, you'll see when it's run, you can click stop to stop. Now it's going to go in, and it didn't do exactly what I wanted. Prompt engineering is not perfect. It's just putting the summary of each article in a bullet point. And you can see it goes through and it's going to summarize each of the different articles. All right, it takes a little bit of time to run through all of this. Different models will run faster or slower than others. And just like in ChatGPT, the context that you can reference things previously in the chat. But now I'm going to show that you can do something a little bit more powerful. I'm going to say, summarize what is similar and different across these set of articles. So now I'm trying to get into synthesize the research so I can start to get oriented on what's going on in this research. And so here's going to list similarities across the articles. Now this is especially valuable for PhD students or scholars new to an area. They can start to get the lay of the land of how things relate to each other and what are the same and what are the differences. This specific one, I won't read all of it, but it goes through and it supports, here's specific factors that are important for earnings management. And then it gives the citations to each one of those articles. And then here are the differences. All right, so there's some differences in focusing on different companies in different countries. There's different methodologies and the implications. Now, watch this second bullet point. I want to focus on the methodology. Well, first before that, it'll also say here's points of tension. So here is Ball's challenging belief that earnings management is rampant, which contradicts with others that say maybe it is rampant. So you can start to see these tensions, and then you can discuss relative to the tension. On the point of tension noted between Ball and Healy and Whalen, flesh out an outline. Okay, so now I'm just going in and it remembers what was talked about before, and it's going to come in here and say, here's the outline. Explanation of earnings management, an overview, and it's going to say the prevalence, it's going to cite Healy and Whalen in there, it's going to be empirical evidence, and suddenly you start to have a framework for understanding this. Now, the purpose of this tool isn't to just go in and say, write me a literature review on these topics, although it can help do that. We don't suggest using this, copy, paste into your paper and you're done. However, this does help on here, and I could say, suggest 3 research questions that would help us understand and solve this tension. Make methodologies suggestions as well. Now, the quality you're going to get out of this is largely dependent on your prompt. I'm just doing quick and easy prompts to kind of show what is possible. But now it's going to suggest research questions. To what extent do managerial characteristics and firm-specific factors influence the prevalence of detection earnings management? And it's going to give some suggestions of how you can do this with methodology. Question 2, etc. It's going to suggest these other ideas. And again, you can continue to delve in and get deeper and deeper in this.
Okay, I will stop here. But I think you already saw examples that we can easily use those tools to do your work, to do your paper, and make things much easier. And you can also decide what's the database you want. And we also find some new applications, and I just want to tell you a little bit details about how they modify that for a specific domain. For example, this idea of Fin-GPT, Fin stands for finance. What they do is basically very similar to a common large language model, but you can say that in their training data set, they have news, social media, company announcement, trends, and data set. Data set is more like a financial data set. And they also have data engineering where they try to do all the query process based on this data set. And for the large language model, it's still similar, but for the application, they just fine-tune it for advisor, for quantitative trading, and low-code development. So you can see that large language model is a general concept, but you can always tailor it to your own domain, from the data set to how you build the app. So it have a lot of applications in the future. And another one I want to show you is called LangChain Overview. This is a little bit long, but to summarize, this LangChain is a system that you can combine different modules flexibly together. I can show you a graph to help you understand. This is one app built on LangChain, and they just have different modules. Maybe one module is for what is the model, another module is how do you manage the memory, another module is how you manage the data set. And for the interface, you can also change like whether I want to use like a client, like I talk to the system, or you want to say, okay, this should be more consistent. I want to have a longer memory chatbot. So everything is flexible, and you can just link all different modules together and create your own chatbot. This one, I think this app is called Blue, but there are other similar apps. You can always find some. You just search, I want to create a GPT bot of my own, and you can find a lot of applications. Okay, finally, we will just have very quick guidance to some very famous models. I would recommend ChatGPT, Cloud3, and Gemini, which are the models I use and I think have good performance. And you can see that their interface are all very similar. You can just use them, and they will have some suggested questions. And then you can also upload files in their chat bar. And you can see there are different models, and they are all similar, and you can also compare. And here is the final suggestions I want to give to you. So first, if you want to see which model just fit your need, you should first, that's easy, just write, you should have a test on all of the models to see the performance, which might meet your needs most, and you use this one. The second one is about the language domain suitability. Maybe you should work on an environment where you will use 2 or 3 different languages. Then you should also test not only for one language, but for all languages to see whether the model can understand different language good enough. The third part is integration and the interface. We know that some models, they have very detailed instructions on how you can get API. Do you know API? API is just a code that you can use it to integrate the model into your own system. It's more like for developer and for people who want to process large amount of data. So you should look at their official website and to see how easy the model can be used, whether it is easier to use, whether it don't have enough guidance for you, and then you use the most user-friendly model. Of course, you also need to consider the cost. Like we said, some models are more expensive than other models. So you also have to check which model to use, especially if you want to use it for a long amount of data or use it in a long time, you should consider the cost. Finally is ethical and privacy consideration. Some models, they have a clear declaration that we will not use your data for training models, and we will not store your data for other purpose. I think I prefer to use those models, but it still depends on the company. You know that if Microsoft said we will not use your data to train any new model, I believe them because it's a large company. In most cases, I believe them. But if I go to a small website and the name is like, okay, most free GPT model, and you never heard of the company, then even if they say we will never train any database on your answers, I should still do more investigation to see who holds that company, whether it's trustable or not. Okay, thank you. This is the presentation today.